Last episode, we built our first agent, and it worked. But did you notice something? Its thinking was completely invisible. It decided which tool to call silently, somewhere inside the model, and we just saw the result. Today, we fix that. We're going to drag the agent's reasoning out into the open, using the single most important pattern in all of agents, ReAct.
ReAct stands for Reason Plus Act, and it's beautifully simple. Instead of letting the model act in silence, we make it work in a visible loop. First, a thought. It reasons out loud about what to do next. Then an action, it calls one tool. Then an observation, we hand back the result. Thought, action, observation, over and over, until it has enough to write a final answer. That running record of its reasoning is called the scratchpad, and it's powerful. You can see exactly why the agent did what it did, which makes agents you can actually debug, and the act of reasoning step by step makes the model plan better too. And we build the whole thing from scratch, no framework. We write a plain text prompt that teaches the model the format. Thought, then action, then wait for an observation. Then a tiny loop does the rest. It reads the model's action, runs the real tool, and feeds the real result back as the observation. There's one catch that trips a lot of people up. A model will cheerfully make up its own observation, just hallucinate the answer. So we don't trust it. We stop the model right after its action and throw away anything it writes past that point. The only observation the agent ever sees is the one we produce by running the actual tool. That one rule is what keeps the agent honest.
So let's check the ReAct in practice and see how it changes the behavior. In the previous episode, we just used our LM and gave the full control to it and told it you are in a loop, just try to find a solution for this problem and give us answer. So the agent kept trying and trying. It had the reason. It wanted to see if he needs the tools or he needs to find some extra information, stack those information on top of each other, and at the end give us the answer. But here, let's see how we can use the ReAct. So we have the same loop. We have the child. We give control to the LM to think about the problem. Also, he can tell us, okay, we need to use this tool with these parameters. But after that, we stop the model from doing anything. We just get the hands, run everything model wanted. So we do the action. After it tells us what action, we get the result as observation and stack it to the conversation and tell the LLM, okay, you wanted to run this tool, I will run it myself. And here is the result. So let's check the code and see where we did add these changes. So everything is like previous episodes. We need a Gemini key. We have our OpenAI client defined here. The model is defined here. We have some tools, population. It can be a database, something like this to get the population of some countries. We have a calculator, and we define the tools here. So the ReAct prompt here is important. Just read it and see how we tell the model to behave. We ask it to solve the problem with the exact format. We have the child. From the beginning, the model should start to think about the solving or doing the task. And then if it needs to run some actions. And after each action, we will do that action, get the results and observation, and stack it to the conversation and give it back to the model. It's a loop. And tell it, okay, now think again. Do we need any other action or not? It's just a loop. And inside the prompt, we say which tools it can use. You will see that we didn't use the function for tools inside the LLM call. We just add it to the prompt here. So we will see how it behaves. Here are some rules, how it should behave. And then we have a task. The task is the combined population of France and Switzerland greater than Germany? So we make sure it can't just create an answer in the first run. It needs to gather some information, do some calculation, and then give us the answer. We have the message again here. It's the system prompt we added here. We have the task, max steps, because we don't want an agent to run forever. It should try, and at the maximum step, it should give us an answer or just stop. Since we want to stop the model at the action phrase, we'll try to find the action phrase inside its answer to stop it or cut it, because sometimes, although we told it, okay, stop it at action, we do the observation, it will continue and get some hallucinations or tries to do something. So now here comes the interesting part, the ReAct loop. We have again our loop, but notice that we have here model, message, and a stop level at observation, temperature equal to 0 to be deterministic. And you will see that in agent, we had the tools. Here we didn't add the tools because we don't want to give the tools to the LLM. We want to make sure that we run it. We are deterministic. We have the function. It wanted the function. We did run it. We got the answer. We put the answer for the LLM. We don't want the LLM to run anything. We want to make sure everything goes correctly, because LLMs hallucinate a lot and we don't want them to just give us an answer even though they didn't run anything, but they find some kind of answers from themselves. So we just cut the LLM answer at the action point, do the observation, and give it the results. So here is the action. We search for the text action. We find where the answer keyword is there, and then we have a stop. So here we will stop doing the loop or going for any more thoughts because we have the answer and there is no action, or if there is an action, it is after the answer, because sometimes the model had the answer, but it says or mentioned that it's better to have that action as well. So we just cut it out and drop the message here to the user. If there is no answer and there is no action, we tell it, okay, try again. It's just an error. We try to give the LLM another chance. Observation not, no valid action found. Use tool name that. And then try again. So what happens here? We have the turn. So here we truncate the text to make sure that we stop after the action. We don't want the model to do anything. That's enough. It says, okay, we need an action. We just append that action into the content. So we know that you wanted to do this action. Then we get the name of that action with the name of variables this action has and try to run it and put it as observation if it exists. If no, we just say unknown tool. And for ourselves, we just print it out. And then after that, we stack it to the message, append it at the end and say, here was the observation. And then go to the next round of our ReAct loop and tell it, okay, the new message is this. You asked for a tool. We run it. The result is this. Now what? Do we need another loop? Do we need another tool? Or do we have all the information? So let's run it and see it in action. So let's see the results together. The task is the combined population of France and Switzerland greater than Germany? If so, by how much? If not, how much bigger is Germany? First, it called the action, get population, observation, we did run it. So we run it, and now the second thought the model has, I have the population of France, now I need the population of Switzerland. This comes from the LLM. And then it says, okay, I need another action, get population of Switzerland. We do the function calling ourselves, get the answer, put it together, and then it says I have the population of both. I need to calculate their combined population. What action is needed? Calculator, this number plus this number, and our observation or our calling is this one. Then the thought says I have the combined population. Now I need the population of Germany to compare. Get population of this country. Thought. Then I have the combined population of France and Switzerland, and the population of Germany is this one. Germany's population is greater. I need to calculate by how much. Then the last action is this one, observation, and the last thought is I have determined that Germany population is greater, and by how much. I can now provide the final answer, and the answer is this. You can now see how the model thinks and how he needs to call these tools. How correct is this? But You almost never write this loop by hand in production. Every frontier model, Cloudy, GPT, even the small, fast ones like Gemini, Flash, has ReAct trained into it. You don't give it a text format, you give it tools as structured schemas, and it reasons and calls them natively. What you just build by hand in this episode, the model now does for you, except the loop. So what we had on the episode 1 is the standard. You have it here, you have the function call, you can just see what functions is called, and you don't need to write it by hand. We just illustrated how the ReAct work in the background. Frontier models ship with native tool function calling. These models are post-trained on tool use trajectories, so reason, then act, then reason, and the result is baked into the weights. That's exactly the ReAct idea internalized. And it's back, I think, from 2022, the ReAct paper that described this behavior, and then it became so familiar and frontier models started to adapt it.
And that's ReAct, the agent reasoning out loud, one thought and one action at a time, until it reaches an answer it can back up. This is the backbone, the pattern behind almost every agent framework you'll ever touch. And now you've written it by hand, so you know exactly what's under the hood. Next episode, we give the agent a real superpower, a web search tool. Instead of a little dictionary of facts, it'll go out and research a question it doesn't already know the answer to. If this vignettes click for you, like and subscribe. The code is in the description, and I'll see you in episode 3.